Good morning. This is Mr. Weiss, and this is 7D Physics on the 5th of May, in case you're watching this video late. And so we're here today. We're going to review turnover in lakes, review temperature and heat, and then talk about, again, the 3 ways to transfer heat energy. So I see somebody's here already, which is great. Let me know, everybody who's here, and I can give you some participation points. Couple of you here. Hey, Mr. Burns is here. Hello, Mick. Glad you could join us. Coco is here as well. Super. There's Jonathan. Hello, Jonathan. Julius is here. Hello, Julius. Aurora and Aaron and Stephanie are all here. Great. Super. And let's see who else is joining us. That's a really good start. Thanks for getting up early. I'm sorry I had to change the time so quickly. Lisa's here too. Very good. Yeah, they gave me duty on Thursday, so I couldn't make our normal hour for our live stream. But this will be okay as well. I've already got a bunch of you here. That's really good. I'll give it just another minute or two, and then we'll start up for the day. In the meantime, you can find your notes from last time if you were here, or if you weren't here, if you watched the video. On density, we have one thing we need to correct, the application in lakes. We'll see what that is. Yeah, then we'll continue with turnover today. And yeah, go back and review some stuff we had earlier in the course. Anyone else here? Let's see. Yep, good. If you're just joining me, please say hi. I see a couple other folks that are here now. So let me know who you are so I can give you some participation points for the day. Great to have you, so many of you up and with me today. Okay, just wait one more minute and then we'll go ahead and begin. I think I'm going to get a marker out right now. Now there's somebody joined us, so say hello so I know who you are. In the meantime, I'm going to start to draw what we had as turnover. There's a lake. So this is kind of a review of last time. So this is springtime. There's a lake, and there's what we call spring turnover. Jonathan asked pencil or pen, and either's fine with me. Whatever you want to write with at home is fine. I like to do some colors, so if you have colored pencils, you can use those too. Okay, so speaking of colors, let's go ahead and begin. So I said in the spring is it starts out really cold and it's icy up here. And the densest water, we know now the densest stuff goes to the bottom of the lake. And what happens here is that the water, when it first it's at 0, but then it warms up to 4 degrees. And when it's 4 degrees, and that's the mistake I made last time. Tilly's here. Thank you, Tilly. Frederica's here too. Thank you, ladies. Good. Anyone else joining us, please let me know, but that's super. Okay, so my mistake last time. So go back and correct your notes. I screwed up. I think I wrote 6 degrees. It's 4 degrees. That's when water is densest. So here's what happens. When the water warms up in the springtime, here's the sun. That's probably the worst sun in the universe, but that's the sun up there. When the sun warms up to 4, suddenly it's denser than the other water. So it goes down and the other water comes up. And that's called turnover. All right. And I've got someone I don't recognize. Image, MRB, subscribe. Let me know who you are. So give me your name. Okay, same thing happens in the fall. So let's look at another lake in the fall. You'll see why I'm telling you this, okay? Oh, that's Mick. Okay. All right, Mick. So turnover, fall turnover. So what happens in the fall is, quite frankly, it gets colder. So let's say the air temperature up here is at like 0 degrees C. Well, then the water starts to cool down. So down here, the water's warm, maybe 10 degrees C, relatively warm. And in the fall, this starts to cool down and give off its heat. And so what's left is water that's maybe 4 degrees C. And of course, what's the 4 degrees C water do? So somebody punch in a little answer. The 4 degrees water is going to do what? It sinks. Thank you, Aurora. So down it goes. The 10-degree water moves up, and that keeps happening. I should write this for both. All right. Turnover keeps happening until UCN is here. Thanks, UCN. There she is. Good. Turnover keeps happening. Oh, Emil as well. Okay, thanks, Emil. Thank you for joining us, everybody. So this keeps happening, whether it's spring or fall. So turnover goes on until all water is 4 degrees C. That's the densest. Once it's 4 and all that water has sunk, then the rest of the water above can either start cooling down or warming up. I want to show you a graph, all right? Hope you can see this. I got this from a physics book and I really like it. Maybe I'll send it to you. I don't know. Here we go. You don't have to write this down, but I want to show it to you. Okay, on this side, I've got volume. So we can think of this as density, more or less, in this case. So when it's most dense, its volume is smallest. So here's where it's most dense. And by golly, look at that. This is the graph for water. So that's 4 degrees Celsius. That's where the water's densest. And here's the weird part. Not only is it less dense when it's colder, it's less dense when it's warmer too. So no matter which way you slice it, spring or fall, this thing goes down. Mick, you know what? If you keep doing this, I'm going to block you. So you got to cut the crap, okay? If you can't either respond to what I'm saying or something else, no more, right? So Emil, Mick, nothing, or I block you both, okay? Last warning. Okay, so that's the deal with turnover. Okay, what's the effect of turnover? I asked you this last time. Let's see if you got some ideas. Tully's here. Thank you, Tully. So here we go. Let's see if you can still see this. Yes, you can. The effects of turnover. Well, now really we're talking about biology. So if the water does this thing twice a year, so what? What does that matter? See if you can give me a couple guesses. Who does it affect and how does it affect something? Okay, who does it affect and how does it affect? Anybody else, if you're just joining us, give me a hello so I know who you are. Let's make sure I got 14 of you. 1, 2, 3, 13. I need about one more of you to say hi. So the effects of turnover, see if you got any guesses. Okay, Aaron says the fishes have to move. Yine, yes. Let's see if you can be a little more specific. What's going on? Okay, Lisa says fish can stay in the lower part of the lake without being in the colder water. Some fish actually like cold water because there's more oxygen in the water. So that's not really the big problem. The big problem is, let's see if somebody guesses it yet. I'll give another moment. It has to do with the fish, though. You're right. When I turn over the lake, something gets stirred up as well. So the water hits the bottom and stirs stuff up. Any other guesses what might be happening? It affects the plants too. Roar's got a guess. Coral cannot live there. Well, coral's not in lakes though. Okay. Yeah. Coral's out in the ocean. Okay, so the effects. The turnover makes the water. How can I put this? The word is turbid. Yeah, it stirs the. That's a good way to say it. Makes the bottom. Let's say it that way. I just saw what Lisa said. So the turnover makes the bottom stir up, and quite frankly, fish can't see as much. So you got a time of year when it's hard for fish to see as well in the water. That affects their nutrition. Exactly. It gets darker and a little dank. That's probably a good way to say it too, Emil. So that's affecting the fish's lives twice a year. Okay. It doesn't last forever, but during turnover, like if you were a fisherman or a fisherwoman, you know what? Probably wouldn't be real great fishing then either because they can't see real well. Okay. On the other hand, it's a healthy thing because bringing up some of that material actually is not bad for the plants. So I'll say, but material from the bottom can help grow algae and stuff that the fish eat. So bottom material can fertilize that's supposed to be a T, fertilize aquatic plants. I'll lean back and I'm going to read that again too. So what I wrote so far is, okay, the effects of turnover. Turnover makes the bottom stir up, and so the fish really don't see as well. That's in the spring and fall while that's happening. And the other thing is, but the bottom material can fertilize the aquatic plants, and ultimately the fish, the ones that eat those, get a good deal out of it because there's more plants that grow at that point. So that's what's up with turnover. Again, we said the really weird thing about water is because it's densest at 4 degrees, that's when water's a liquid. Water is one of the very few substances where the solid what? So see if you can remember that from last time. water. It's one of the very few substances where the solid what? I'll just write here, recall solid water. Let's see if I got a response from somebody or other. Tully says it weighs less than water. No. Yes, no, you're right. Although weight is not the word. Like I could have a bunch of ice and a little bit of water, or a little bit of ice and a bunch of water. I think you want another word. I got a couple other guesses. The solid floats. Yes, Stephanie. Why? The water expands when you freeze it and floats on water. Right. I want a word from you, all of you, that starts with D. So try and use a D word in a sentence. Don't just give me the word, but tell me how it applies here. So solid water compared to liquid water. And yes, it does float on the top. We know that. So solid water, we're talking about ice. Is there you go. Now I got it. Good. Okay. Right. So the word is density. So we say solid water ice is less dense than liquid water. Yeah. So obviously you're all right. It floats. Exactly. Good. Stephanie's got it as well. Nice. So that's kind of what we've got with density. Questions from you about density. That's not the only application, turnover, but I always feel that's a kind of interesting biology application. So any other questions about turnover before we go? I'll just kind of hesitate and make sure everybody's got the board written down. Who still needs to write a little bit? There are not a lot of substances that do this same thing where the solid is less dense. For most every other substance, the solid is the most dense phase, okay? So you got to know water is a really important exception. It's an exception, but we see it all the time. So maybe we're used to it. We're used to seeing like ice cubes in our water, right? And they float. That's just, we know that. But we never thought it was weird maybe until now. Normally solid phase is denser and falls to the bottom. Okay? All right. Good. I'm going to change boards. I got two now. I ordered a second one. And we're going to change subjects a little bit too. So here we go. So we're going to take our turnover board and set that down here. I may erase that in a little bit. I'm going to take my other board, put it up here, and hope it doesn't fall over. All right, we'll give it a try. By the way, I don't have 14 people. I got 13. I'm just going to read off who I've got. I got Tilly, Aurora, Mick, UCN. I've got Tully, Jonathan. I got Lisa, Julius, Coco, Emil. I got Aaron, Stephanie, and Federica. Anybody else out there that I don't have written down? Let me know if you haven't said hello yet. Okay, so let's go to a new subject, which is an old subject. My 10th graders have a problem, and that is they still don't get the answer to this question. This is a review question for you. We were even together in the classroom when I told you about this, but I want to see if you can still tell me. All right, so you can type in when you know an answer. What's the difference? I'll write diff for difference between heat and temperature. Again, it should be a review question. Let's see if you can punch in with stuff you remember. Flip back if you want to look at your notes from a few weeks ago when I actually talked about this with you in February. Let's see if you can remember it or find it. Okay? What's the difference between heat and temperature? They are not the same thing. Good. I got one answer already. Let's get a couple more. Okay, Aurora's got an answer. Heat's the energy of an object that it has, and temperature is the measurement of this energy. Yain, both are partially right. Julius adds, heat is energy and temperature is a measurement. Yes, also right, but not 100% there. Let's see if anybody else can give me a more exact idea. So, yes, you're both on the right track, but you're not all the way there yet. Let's see if someone else can add to that. Maybe somebody can find it in their notes. That'd be cool too. Well, let's make a little spot here. So I'm going to say heat is, and down below that, I'm going to say temperature is. And now I'm going to look and see if any other response. And yes. Yep, good. I got several responses. Good. And UCN has it. Very good, UCN. We're going to do temperature second. And we're going to do heat first. I'm going to take the first thing she said. Okay, she says heat is, and I like the way you said that, UCN. Heat is the total energy of movement. Remember how I had to move around the first couple days of class? The total energy of movement of all the molecules or all the particles in a container. So underline the word total. That's really important. Yeah, good, good. And Tilly has added a good word. And the energy of movement, and I couldn't remember if I told you this, Tilly, or not, but apparently I did. Energy of movement or energy of motion. Drop the marker. Energy of movement is called kinetic energy. You'll need that next year for sure. Okay, so heat's the total energy of movement, called kinetic energy, of all the particles in a container. So if I got two containers, one here and a big one, if they're the same temperature, then the big one has a lot more heat. Okay, temperature is, and we'll go back to what UCN and others said, including Lisa and Stephanie as well. Very good, everybody. And Emil has as well. He said now heat is the total energy, and that's really true about it. Okay, so now let's go to temperature. Temperature is the average energy of movement. Or you can just write kinetic energy of particles in a container. You know what? I'm not even going to say in a container, because what if I took the temperature outside, right? I don't really have it in a container, but I can still get the average. Like if I hold my thermometer outside, I can get the average temperature out there. The average energy of the particles out there. That's just the temperature. So maybe today it's like 10 degrees out. Okay. That's the average of all the particles bumping into my thermometer. They bump in and they make the little particles inside bump more, just like we did walking around the classroom. And they rise up until they hit the 10-degree mark because they're little liquid in there expands when they get warm and start to move more. Right on. If you understand that, you're better off than a lot of my 10th graders. I'm going to read any other comments you got, and then we'll continue. But that's a really big deal for 7th grade. If you got that, that's good. Let's see if there's any other comments I need to address here. Lots of good. Yes, you got it. Okay. Righto. All right, good. Then we're going to now change gears and review something else. And that is 3 ways to transfer heat. Three ways to transfer heat. 2 of these ways are going to be reviewed. You and I talked about them in the classroom. The third way we didn't get to, and we're going to spend time today and next time talking about this third way. But let's review the first couple of ways already. So the third way, I can't remember if I gave you reading on it or not, but if not, I think that's the next assignment I'll give you. It's short, so don't get all worried. Take you maybe 10 minutes to read and answer a couple questions. But I'll send that in the Google Classroom once I figure out that assignment. So let's see. 3 ways to transfer heat. Can somebody give me one way? I got a hot object and I want it to transfer heat. What's one thing, one way physics say? Look back in your notes, see if you can find one of 2 different words, and I'll give you a moment. And if you don't get it, I'll give you the first letter of those words. But let's see if somebody can find one way to transfer heat. Good. I got some people printing. And over metal, yes, Jonathan, but what way do metals transfer heat? Like I have a piece of hot metal, it can transfer its heat 2 different ways, or maybe 3. I need to how it transfers the heat. You can place them next to each other. Yes, now we're getting warmer. Ha ha ha. Okay, so if I take a piece of metal that's hot and a piece of metal that's cold and I put them next to each other, they transfer heat by What's that process? Yes, good. I can put them on top of each other, Aaron, too. It doesn't matter. If they're touching, they transfer heat by what method? It starts with a C. It's the same method if you have your feet on a cold floor. The heat from your feet gets transferred to the floor. Yes, Lisa, by touching, but that's not the method's name. Ooh, it's a good thing I asked this because this is essential for 8th grade. Okay. Collusion, Lisa, you're close, but that's not it. Ah, I'll give you a next letter. C-O. C-O. You want a third one? Oh, Aurora's got it. Okay, Aurora's looked it up here or remembered it. Good. Here we go. So it's called conduction. Conduction. Okay. Wow. All right. Let's make sure we know that. So let's see if any other comments. Right. Okay. So what happens is the particles that are hot particles. Okay. Particles moving more. In other words, they're hotter. hit particles that are cooler, and they make them move more. Doesn't that make sense? Remember when you and I were bumping around the classroom? Well, what if some of those hot people hit cold people? They'd make them move more. So they transfer energy, but they have to physically be touching each other. That's what a lot of you said earlier, touching one thing on another. You're all right. But that's what's happening at the particle level, okay? So particles moving more, hotter particles, hit particles that are cooler, and give them energy. It's actually kinetic energy. So they move more. So it's pretty simple. And can you still see that? Yes, you can. And I'll add down here, the particles must be in direct contact, must be touching, must be laying on each other. So I should say that objects must be in direct contact. They must be touching. And while you're writing, I'm going to erase my board. So you write, and let me get my magic eraser, and I'll get the other board ready again, all right? So stand by. I'll be back. Got my fancy new eraser. Just got it in the mail. Oh, it's working so good. I'm all set for live streaming with you. Okay, let me make sure. That's kind of hard to see. Let me make sure you can read that, okay? I'm going to tilt that forward. And let me reread it before I change boards. Okay, so 3 ways to transfer heat. One way is called conduction. Particles moving more, the hotter ones, hit particles that are cooler and give them energy. So they move more. And objects must be in direct contact. Okay. Let's do a brand new board. And let's talk about a couple examples. I'm going to give you one example. Let's see if you guys can give me some more. All right. One example is I touch a doorknob and it feels cold. Well, it feels cold because it's taking heat from you. So right here, because you give the doorknob heat. Okay. Can you think of any other examples of when things are touching and one thing is giving heat to the colder thing? Think wintertime. What else could you think of? Let me look at my book and see if I got another cool example. Any other examples of conduction? give you another one. In bed. When you touch cold ice and it melts. Yes, good, Julius. All right, so just the one I was looking for. Hold a snowball in winter and it melts as heat moves from your hand. Good one, Julius. Let's see if anybody else has got one. Touching your friend. Yeah, okay. If your friend is like really cold and your hand is warm and you touch them, you're going to transfer heat. So that's true, Lisa. Let's see. I got one from Tully. When you touch a frying pan on the stove, it's hot. Oh, that's a good one. I like that. So I'm going to put some little dashes here. Okay. Touch a hot frying pan. I don't think that requires any explanation other than to say, ouch. Yeah, very good. Let's see if I got another one or two. When you step on cold tiles, Aurora, absolutely. Yep, good. That's actually great. 3 examples is fine. 3 examples is fine. Let's do the second way to transfer heat. I think you guys got the first way pretty well. So, got to be directly touching. The second way, oh, let me think a second. 7th grade physics, second semester. I don't think we talked about this. I think we had a reading assignment about this, but we didn't talk about it. So when I review it this time, I'm going to make sure we have several examples of this. And then we'll get to our third way maybe next time. We'll see. Okay, second way. So the first way to transfer heat was conduction. Okay, 3 ways to transfer heat. Conduction. The second way starts with a C also. So the second way is called Do you remember it from the reading, anybody? It was in the reading assignment. And hint, turnover has to do with it, although we didn't talk about it at the time. Any guesses? So aside from conduction, we have cohesion. I got a couple. Okay, good. Stephanie's got it. Aurora's got it. So it's called convection. Convection. And this has to do with density. So it's the reason that lake water moves is because of convection. Okay, so these are currents that transfer hot particles into cold particles. Thereby spreading heat. So you're bringing in a bunch of hot particles, essentially. Okie dokie. Let's talk about do I want to talk about boiling water? I kind of do, but I want to make sure I've got my terms straight here. Okay, I want to show you something. I know this stinks. I wish I had this, but you can look at this on the internet and you'll find a similar drawing. Okay, so if I heat up water, so let's look at this graph. I know the graph on the bottom only goes from like 0 to 20. But let's say I start with some cool water. It would continue on here. So I put some water on the stove in a pot and I start to heat it up, and the water at the bottom gets less dense, right? It gets less dense, and so it's taking up more volume. And so when it gets less dense, where does the hot water go that forms at the bottom of the pot? So again, here's my pot. I heat the bottom, so the bottom water gets hot and it's less dense. So where does it go? I'm going to draw a pot. At least I'll try and draw a pot. Let's see if you guys can draw a better one at home than I do. My art skills are not the best. Here we go. So there's my pot, one of my better pots. Here's some water. Here's my burner. I'll just put a little flame here. You get the idea. It could be a Bunsen burner, right? It rises, yeah, to the top, exactly. Jonathan, Aurora have it. So I get this hot water, and it's less dense. And so the hot water goes up. Whoa, it rises up. And the cool water, and we know that's densest when it's cooler, right? Closer to 4 degrees, that sinks. So what happens is, I'm going to put a little star here. Okay, let me read this. Okay, so current that transfers hot particles into cold particles spreading heat. Okay, so this puppy right here, you ready? It's called a convection current. You know, like a current in a stream, a river? So a convection current. And Julius, it doesn't vaporize. We're not talking about up at the surface yet. We're just talking about the water in the pot. So we're not talking about that. That's a very different process. Just talking about moving the heat around in here. So a convection current begins as soon as a difference in density is present. This turns out to be really important. Let me let you catch up because I know we're getting close here to the end of the hour. So here's my hot pot. So we'll say hot water. It doesn't even have to be boiling yet. It can just be already starting to warm up as soon as it starts up. And if you do this on the stove and you watch, you can actually see some of the water moving around, and that's the convection current. And if you got something, this might be cool to try. If you got any dye, any like little granules or little liquid dye, right, barber stuff, if you got this, just while it's starting, like turn the water on, wait like a minute or two, and then put a drop or two, and you're going to see the drop go like this. Okay, until it starts to get all the same color. So you're going to see that convection current if you can put something in there that will go around like this in the water. Guaranteed. Okay, guaranteed. So that's a convection current starting up. In regular water, if it's all the same temperature, you don't get it. But as soon as I get a difference in density, so as soon as the hot stuff, which is less dense, forms at the bottom, it rises up, the cool stuff comes down. Great. We've got a hugely important application for that. And it has to do with, yes, the hour's over, thank you. The hour has to do with what we'll start with next time, and it's called plate tectonics. In other words, the Earth's tectonic plates. You're riding on big giant plates if you didn't know that. We're going to find out about that next time. They're driven by convection currents. So that's kind of the scoop. And then the third way, I'll give you an assignment for, but it's called radiation. Can you read it aloud? I cannot read something. Yes, I can. Okay, so convection current that transfers hot particles into cold particles, spreading heat, hot water. And here I got a convection current begins as soon as a difference in density is present. So I hope, Jonathan, that helps. The hour is over. I'll see you next week when we can meet. If we have vacation Thursday, we may be meeting Tuesday again. Thank you so many of you for being there and participating. Have a really good day, and bye-bye. Stay healthy.